Hello, this is Naz from NB Network Lessons. Hope everyone's doing okay. My today's calculus lesson 62, we're going to solve a couple of more problems by using integration by parts. This is a practice session, so basically what I'm trying to do is I'm trying to give you a flavor of different kind of problems which you might see in your exam. So without any further ado, let's go ahead and get started. So let's say the first problem is, they say find integral of natural log of x dx. How would you do that? By using integration by parts. Well, first thing is that I can write this as natural log of x times 1 times dx. It's the same thing. Dx multiplied by 1 is still dx. And I'm using this and I'm doing this because I want to basically come up and make natural log of x as u, okay, and make this right here as dv, right? So just a simplification, to make it look nice. So then once I have this, I can say if u is equal to natural log of x, then du with respect to dx, what is the derivative of natural log of x? 1 over x. So then we have 1 over x. All right, or we can just say du is equal to 1 over x times dx. Easy peasy. All right, now let's go ahead and deal with the dv. All right, so we said dv is equal to dx. Okay, take the antiderivative of both sides. In other words, take integral. So then v is going to be equal to x. Pretty straightforward. Now what we do is that we come back to this formula right here, okay, and we apply it. So what is u? U is natural log of x and v is just x. So we say x times natural log of x minus integral of v, which is x. What was du? We calculated du right here. So it's going to be time 1 over x times dx. Straight away I can cancel this x with this x, and then I am left with x times natural log of x minus dx. All right, now what you have to do is you have to just take integral of dx, which is x. So then the answer is x times natural log of x minus x, and never forget the constant c, initial value. So that is my friend's answer. So how's that? Not bad, not bad. So let me come back in my next lesson and solve one more problem, because that might take a little bit more time. It's a little bit longer problem. So thank you for watching. I will be back. Take care of yourself. Hello, this is Nat from NB Network Lessons. Hope everyone's doing okay. Welcome to all of my students around the world. Thank you for joining. In my last lecture, lesson number 60, we derived the formula for integration by parts, which was this right here. And in this lesson 61, I'm going to try to see if I can solve an example, which would, in that way, it will make sense. I'll show you how we are using this formula, how are we applying this formula to solve a problem. Okay, so let's say we have, says find integral of, we have, let's say, x into cosine of x dx. Okay, so we have to apply integration. We have to solve this through integration by parts. So what we can do is we can say, okay, let's say this part right here we make it u, and this part right here we make it v. all right? So if I substitute u for x, then du over dx, change of u with respect to x, is going to be 1. And I can say then du is equal to dx. All right, no rocket science, just pretty easy peasy derivation. Now, we said we're going to say dv, we say dv is equal to cosine of x, okay? Now, if I ask you to take antiderivative or integral of both sides, what will you get? If you take integral or antiderivative of both sides, you will get v is equal to sine x, right? So now what we can do is we can go ahead and use this formula right here and try to solve this. So then I can say, using this formula right here, I can say x into sine of x, uv, u is right here, x, v is sine of x, right? And then minus integral of, what is v? Sine x. What is du? dx. Okay, so this is what we get. Now, it should be pretty straightforward to solve this. So we say x into sine x, we take the integral of this, okay? Integral of this, sine x is going to be cosine x, plus c, constant, the initial value, and that is my friend's answer. So how's that? So you just got to come up with u, and v, and then you take the derivative of the u, all right, and you take the integral of v right here. You come up with this sort of table, and then you plug in the values using this formula right here, and that's it. Hope you learned something. I hope so that you will go back and solve some problems from your homework, from your textbook, and I will see you next time. Take care of yourself.